position, velocity, acceleration, and speed. So we're going to do a lot more with that. So we're going to know how position, velocity, and acceleration are related. And again, we've talked about that. We're just going to do more. And then the other one, we're going to talk about how v of t and velocity and speed are related. This is the first year I've kind of inserted this extra day to this part. Hopefully it will help in the long run. Okay. Taking the time to do more with it. Okay, so we've already talked about how the first derivative of position is velocity, and that the absolute value of velocity is speed. We've also talked about how the second derivative of position, the first derivative of velocity, is acceleration. So all of that we know. Does everybody feel okay with that process? All right. Let's take a look at some of these graphs and answer some questions together. So this first graph is the graph of what? Position, velocity, or acceleration?
Velocity.
Okay, so it tells me it's velocity. So let's look at these and let's find where speed is increasing and where speed is decreasing. So we can do this a couple ways. Uh-huh.
Because think about it, guys, when is it getting close to zero and when is it getting farther away from zero?
What do you mean by it?
Velocity.
When is velocity getting closer to zero?
Is it getting farther away from zero?
Okay, so you said when, so can you give me as like a, when velocity is what?
Getting farther away from zero,
Then what's happening?
speed is increasing. When dt is getting closer to zero,
Okay, so that's how you explain it there. Okay, we can look at that as we kind of keep going too. And I'm going to show you some other ways that I think of it, okay? So one way that we can do is that we can take our velocity graph and we can do the absolute value. Because when we take the absolute value, it's what we call the absolute value of velocity is speed. Yes? So in this next one, I can see that I have the absolute value going on of what was just prior. Agreed? Okay, so here, if I want to talk about where speed is increasing, now I can see I am increasing and I am increasing. Do you agree? So that's one thing that I can do. So for the increasing interval, I could graph it and just like do the absolute value and find where the graph is going up. Where is the graph increasing? So in this case, we would say from 3 to 4 and 9 to 11. It looks like that goes at 4. You think it goes to 5? Sorry. Okay, thanks. It's hard to see, isn't it? Mine was really... Okay, so to 5. I'm going to fix that. Thank you, guys. Okay. Do you agree with the 9 to 11? Yeah, okay. So tiny. Thank you. Okay, so then the decreasing part, if I'm looking where I'm decreasing, here I'm decreasing, and here I'm decreasing. So what interval is that?
2 to
Okay, I got that. Okay, so agreed. 2 to 3 and 6 to 9. Maybe yellow wasn't the best choice there. Okay. And then constant, we can see we're constant here and here. So let's put those intervals where we are constant.
0, 2, 5, 6.
Yes. Okay, so say it. Okay. Velocity is below the x-axis. Yeah. Okay.
So it could be going down. The speed could be increasing as it goes.
Yes. So again, we can think of it as the absolute value. And another thing that can help us that we're going to learn about here is going to be acceleration. Okay. So if you are going to the left with a negative acceleration as well, then you are speeding up. If you're going to the right with a positive acceleration, then you are speeding up. We're going to talk about those in the science here in a little bit, okay? Okay. You're welcome. Okay, and then if I wanted to, I could graph the acceleration function. So the acceleration function sends all of these slopes up here from velocity, right? So we're going to come back and look at velocity. All of that slope is horizontal, so I know the derivative has to be 0. So it's going to be a piecewise function. So here I can see my derivative is 0 on that part right there. Okay, this guy going on, when my slope is, we can do rise over run, I think. What's that slope going to be? Down 3 over 1. So it looks like a -3 for that slope. Agreed? So then I know that that's linear, so the derivative is going to end up being a horizontal, and it's going to be at -3. And see if you can understand where these other two pieces came from. See if they make sense. Okay, so any more questions? I get you guys helping each other. That's awesome. Any more questions where these last two pieces came from? Okay, did you guys hear Allie's question? Just how do I know that these holes are open? So let's go back up to our original, and this was my velocity graph. If I was looking at this graph, what would I count that as? What's it called right there? A corner. Am I differentiable at a corner? No. So the derivative will not exist at that value. Okay, up to right here, the derivative is not going to exist because it's at that corner. You're welcome. Good question. Yes. How do I know the what? This guy right here? I'm not understanding. Can you guys help me? Come show me what you Oh, just y in general? It's just an example. That So we don't know yet, okay, like what's going on. We'll get into more board problems as we go. This was just saying, if that's the graph, can you interpret the rest? Yeah. So I don't know why it's at 3 right now. I'd have to see why I have a velocity of 3. I don't know the problem. Okay? Okay. So now I want you guys to look at your, keep on this page, okay? Don't flip yet. Look at your velocity and look at your acceleration graphs. Tell me when they have the same signs. So tell me when are velocity and acceleration both positive, positive, or both negative, negative? Okay, so look on those two graphs and see if you can tell me the intervals on when velocity and acceleration have the same sign. And just so we're on the same page, I'm looking at velocity. Velocity is positive here, right? This is where velocity is positive, and then velocity is negative here. So that's where velocity is negative. Agreed? And then if I'm looking on my acceleration graph, let's not do that. Okay, so if I'm looking on my acceleration graph, here's where the acceleration is negative, and here's where acceleration is positive. Okay? So see if you can formulate the intervals with your buddies on when they're both positive and they're both negative.
3 to 5, 9 to 11.
With your squad. You guys have the interval.
Good job.
So velocity and acceleration are both positive from where to where?
0 to 2.
9 to 11
3 to 5.
is where they're both positive, and where are they both negative? 3 to 5 is where they're both negative. Where else did we see that interval? Oh! Okay, so we saw that where we are speeding up, increasing, so where we are speeding up here is the same thing. So this is another way that we can tell speed is increasing when v of t and a of t have the same sign. So where they're positive, positive, or negative, negative. Okay? So speed is going to be increasing when those guys have the same sign. And we won't always get to look at the graphs. We may end up having to do some work to figure that out. So then where is speed decreasing? Yeah. So positive, negative, or negative, positive, basically, right? So when they have the opposite sign, speed is decreasing. And then the last one, just so we're okay, when speed constant. See if you can think about. Go ahead.
When AT.
AT. Speed is constant when here, hold on. Speed is constant. Oh, when you're accelerating, sorry, yes. When a of t is 0, so when that derivative, that slope is 0. Very good. Sorry about that. He goes, yes. Sorry.
I know my physics. Sometimes this major elective
So then, what happens when v of t equals 0? What's happening when v of t equals 0?
it's not moving.
So when v of t equals 0, what's happening? Speed is 0, or so like think about our graph. If I had some v of t, let's be like that.
Changing direction.
Okay, so it could be changing directions, but yeah, it's not moving. Kind of, it's like in the limbo state. It could be changing directions. What if it's like that though? It just was kind of like, I'm gonna go right, but I'm gonna keep going right, you know? So yeah, if it crosses through, then it changes directions. But if it doesn't cross through, is it changing directions? It's just kind of like going right. Yeah, I'm gonna keep going. Like you kind of had that little thought process where you're going left and you're like, wait a second. Oh yeah, yeah. Maybe stop at a stop sign really quick. There's a roll through, right? It's just like, okay. Okay. So we're gonna get our graphing calculator out. Go ahead. No, please look at the graphing calculator. Okay, so on this example, they give us the velocity, and this is between 0 and 5. And they give us some other information that I start actually at time 0, my position is 10. I don't know 10 what exactly, but at position 0, I started at 10. So it's like maybe I got a little bit of a head start. Okay.
10 meters per second, 10 feet, 10 meters.
Right.
10
So
miles, 10 kilometers.
yeah. It's like the tortoise and the hare. Maybe they said, "Hey, go ahead and get a head start on me." So when we started out. Okay. So find all the values of t in the interval 2 to 4 for which the speed of the particle is 2. Well, if I want where the speed is 2, so I'm looking in part A, where the speed equals 2. So what is my equation for speed? Absolute value of velocity. So I'm going to do the absolute value of this guy. And I want to see where it equals 2. How are we going to find that in our calculator?
Go into the catalog.
So, and again, I only want it on the interval from 0 to 5, right? No, what did it say? Actually, they gave me a smaller interval. They said from 2 to 4 in part A. Ooh, yeah, pay attention. Okay. So how many of you guys said I could find the intersection? I could like put that in y1, put that in y2, and find the intersection. That's a possibility. How many of you guys said I'm going to subtract 2 over, set it equal to 0, and find my 0? That's what I would have done. Okay. How many of you said I'm going to try my solver on my TI-89? Oh. You have a solve feature, and it says solve, and then you can do the function. So you can plug all of that in. You can even have it equaling 2, and you can say you want to solve for x. Okay? Personally, though, I really like graphing, so I would put in y1 the absolute value of all of that stuff minus 2. That's what I would do, and I would go and I'd look for the zeros in this interval. To me, I think that's the quickest way. You guys all know how to find absolute value.
Yeah, go to your catalog.
Catalog's probably the easiest way. If you need help plugging that in, I will help you. So then once you have that, there's actually 2 values that you should get. I'm going to put the values up here and see if you can get them. And how many decimal places do we have to go to? 3. So see if you get those 2 values. I'll come around and help you if you're not getting those 2 values. And again, you only have to look at the window of the x-axis from 2 to 4 if you want to change your window. Uh-huh. Here. Way is to graph and do, like, always set it equal to 0 and find your C. Okay. So if you only graph that part, then you graph the 2 for the intersection. I like it. I will graph this part. And I'll like bring over the 2. So minus 2. So now I've set it equal to 0. And now when I do the graph, I can look for my zeros. And now you should get those guys out and you look for the zeros between 2 and 4. Yes. See the catalog? Okay. doing okay? Everybody here has one? What about over here? Do y'all have it?
It's a little like we have a game every Friday. So like boy well no, I was not in my community with
Plus,
I know.
where did I put it? Don't worry about it.
no, I think something's great.
Why did you She should go with me.
Where you at?
I'm actually.
Yeah, that's what
Yes, yes. I don't know. I think it's easier to graph and find the same rules. Okay, so we're going to go on to B now. Okay, so we're going to go on to part B and keep your calculators because we're going to need them. On part B, they want to know, is the speed increasing or decreasing? Okay, so what I'm going to do, and it says at time 4, is if I find B of 4 and I find A of 4, and let's say that they had the same sign, either plus plus or minus minus, what could I say? The speed is what? Increasing. But if they had any kind of opposite signs, what would I say? Speed is decreasing. So this is what I want to do. B of 4 is easy to find because they gave me B already. A of 4, what do I first have to do? Yeah, first find A of t, excuse me, by finding that derivative. Now you have your calculator. If you have only the 84, you're still okay because it's going to have you do the derivative and it's going to say evaluated at a point. Remember how it has that open box? So you can do that derivative and plug in 4. Okay? If you have the 89, then you're going to take the derivative and then go plug in the 4 to your A of t. So I want you to see if you can find B of 4 and A of 4, and I will come around and help you. You want me to do it on my 84?
Please.
Okay.
Maybe.
Alright, so here. Just to find B of 4, are you guys okay with that? Is anybody not okay finding B of 4? You just plug in the point. Okay, so B of 4, what did you guys get out? Negative 11.475 something. Okay, finish. Okay, so you can truncate or round. Yeah, you don't like truncating, you want to round. Okay, so now let's go here. I'm going to find my derivatives. So math, number 8. And I'm just going to use x's instead of t's. So I'm going to take the derivative of x. Can't see what I just wrote. And then I'm going to put in that anywhere here for A of t and B of t? No. We only are using those when we do the speed. Okay?
How did you get through nine?
So I went math and number 8. Okay, so if you're using the 89, I can help too. If you just go to F4, did you find the derivative? And it has like the d. Did you find it? Oh, 83s.
Yeah. I gotta go get the 89 and just do lazy.
So either 89 or 84. Okay. Okay, so now I'm gonna put my variable.
What the teacher Okay, is that what you guys got?
What? Mine won't.
Oh yeah, that's so true, yeah. So that could save a lot of time, yeah. If you have it in your Y1, you could just put, what is it, Y bars. So you could do that too, what? Okay, yeah, or copy paste it or something, it maybe would have been faster. Okay, so this guy, if I go back, is negative, oh, I just lost it, 22, thank you. Okay, so help your buddies out, okay? Some people didn't get it yet. Help them out before we move on. It's hard for me to help every single person, so I need you guys to help with what's going on.
My calculator won't let me put it like to a color. Did it?
Okay. So, now that I have this information, what can I say?
Speed increase.
Speed, answer the question. Speed is increasing. Why? Because A of 4 and B of 4 have the same sign. Sorry, increasing at time equals 4, right? So speed is increasing at time equals 4 because A of 4 and B of 4 have the same sign. Okay, go to the next one. I want you guys to see if you can, hold on really quick. I want you guys to see if you can do this next one with your buddies. I won't switch it yet, some of you guys are still writing, but see if you can do this example. And I'm going to give you 3 minutes. Go.
Otherwise, you can just actually we want it out of joint. That's why I like you guys to have okay.
So that's position. Graph the derivative of position. Well, did you do your graphs first? Okay.
Good morning, Park Hill. It's Thursday, September 8th, and it's a red day. Student of the day, Brianna Quintera, nominated by Mrs. Tuck for being hardworking, polite, respectful, starting each day with a smile. Pick up your cookie coupon in the office. Today's student
How'd you
birthday,
do on this?
Dayton Johnson, Janet Medalena, Ashley Spalding,
Okay.
Emily Wickerham, and Allison
So remember velocity, these are all linear things, so I can say this slope is 0, this slope is -4, this slope is 1, that slope is 0.
Evelyn Kirtley, and Garrett Rayner.
Those are all linear.
Today's staff birthday,
Speed, I just take the absolute value of that.
Everybody. Culinary Club will have a brief meeting today after school to finalize
So,
plans for homecoming.
When is the particle moving to the left?
Attention all students.
It's when velocity is what?
Mr. Kravitz will be holding a review session
Negative.
today.
Moving to the right is when velocity is,
Will be served, so come out and learn some
and
Latin.
standing still is when velocity
Sign up to the
is.
counselor's office.
So see if you can go get those
Park Hill South
intervals.
Soccer families will team up against the 4th annual Kick-Out Cancer Classic. All proceeds from the night will be donated to Sporting Kansas City's Victory Project, a foundation dedicated to helping area kids fight their battles with cancer.
It
The triple
moved.
header starts at 3:30 with
It moved.
16, JV at 5:30, and
It
varsity
moved,
at
see?
7. Coming out,
They,
like
like,
a great
moved up.
rivalry, and let's fight cancer.
So annoying. So don't look at that.
The homecoming
moved
dance
up.
is Saturday, September 17th. If you plan to bring a guest, you must fill out a permission slip. This one must be completed and submitted to the activities office by Wednesday, September 14th, before a dance ticket can be purchased. Please see Ms. Peterson in the office with questions. And speaking of homecoming, homecoming dance tickets will be sold during all lunch shifts. One ticket for $10 and two for $15. Hey, that's a bargain.
Okay, so see if you got those. And then when is the particle moving the fastest? It's when your speed is greatest,
Girls basketball meeting in the upper gym.
which is actually from 2 to 4.
15 for all girls interested in playing this winter. If you have any questions, please talk to Coach Neeser. Any students who purchase the school picture packet of registration may pick up their photos during.
Okay, so you guys, if you want to do more of the notes with me, we can. Otherwise, you are good. You can do your homework, and we don't need to do more of them. It's just kind of extra practice. Yes, motion homework.
The large group room.
Next one, do is 2.3.
All are welcome. Let's get to Dr.